Today, I'm going to introduce a new challenge question of Jumping to STEM program, which is building energy audits for residential or commercial buildings. According to energy usage data by the U.S. Energy Information Administration, residential and commercial building consumes about 38% of total U.S. energy, or about 40 quadrillion British turbine units. And HVAC system consumes more than 30% of total energy used for residential and 44% for commercial building. Buildings, whether long-standing or recently constructed, have potential for energy improvements. Engineers uncover the energy improvement potential for these buildings through inspection, survey of systems, and review of past energy uses, a practice commonly referred to as an energy audit. Energy audit is part of the overall energy program and official examination and verification of accounts and records. An energy audit can be performed in both residential and the commercial building to identify opportunities to improve energy efficiency while maintaining or improving occupants' comfort. In addition to this, energy audit can be used for energy efficient building certification, such as Home Energy Rating System Program and LEED certificate. The energy audit can range from a simple walkthrough of the building to a detailed audit with on-site measurement, tests, and analysis of many building systems. ASHRAE provides industry with 3 standardized levels of energy audits. Level 1 audit include a review of utility bills, interviews with building staff, and a walkthrough of the building. The purpose of this audit is to identify energy inefficiency and provide recommendations to building owners regarding operational adjustments or system upgrades with cost-effective energy efficient measures. For example, by analyzing energy bills, the fuel and the energy type used can be identified. Any anomalies or changes in historical patterns can be identified as well. By calculating energy use indices, energy use of the building can be compared to similar building types regionally and nationally. By conducting a walkthrough of the building or interview with building staff, customer concerns and these needs can be identified as well. Major problem areas can be uncovered by simple energy audits, but level 1 energy audits are often not sufficient for implementing more significant measures, and in that case, more detailed energy audits are recommended. Also, the lack of granularity of utility bills reduces the potential for diagnostics and other data processing techniques. In addition, many buildings today are equipped with a vast array of sensors that could provide more meaningful analysis and insight into a building's operation. Level 2 audits includes more detailed building survey and energy analysis. For example, utility rates are analyzed to determine if there are rate change opportunities and potential problem areas. By examining construction documents and performing a comprehensive on-site visit, the condition of building envelope and HVAC system and operation and maintenance procedure can be identified, and a baseline for energy usage can be developed to evaluate the cost effectiveness of the pre-selected energy efficient measures. Level 3 audit is the most rigorous analysis of them all and involves the most field data gathering. Existing utility data is often coupled with sub-metering data as well as continued monitoring of operation systems. The focus of this energy audit is detailed analysis of capital-intensive modification. For example, detailed building energy model using energy simulation software such as Energy Plus Open Studio is used and validated from data gathering. And detailed project cost and savings calculation, including return of investment with a high level of confidence is provided. This level is typically used on industrial and commercial buildings and considered investment grade. In detailed energy audits, such as level 2 and level 3, to examine the current condition of building envelope or HVAC system and operation and maintenance procedures, additional diagnostic tools can be used. One example is a blow-door test. The air leakage of the building can be estimated by a blow-door test, or tracer gas test can be performed to identify air leakage or determine the air tightness of the building. Tracer gas tests use emitter and receiver devices. The concentration of a tracer gas in a room can be determined in addition to the rate it circulates through the home. The other example is air camera. Insulating level of the building still can be identified based on as-built drawing. However, thermal bridging or insufficient insulation can be identified using an IR camera together with a blow-door test. Also, to develop a baseline for energy usage of the building or to evaluate the prioritized potential energy efficient measures, which are usually identified through detailed energy audits, whole building energy simulation tools can be used. Many tools are available, and here are the list of frequently used softwares for both residential and commercial building. Besides this, remote building energy audit services using new technologies such as advanced data mining techniques or machine learnings are under active development as well. Here is a challenge question. The Jump into STEM competition is looking for technical solutions to expedite audit process or develop a simplified but more efficient audit method by finding ways to reduce time and cost. Detailed audits are more expensive and time consuming, and they require more detailed field data, but can be necessary to plan an appropriate path forward. Because level 2 and level 3 audits are expensive, they are not performed often, especially for residential buildings. So significant energy savings are left unrealized. More specifically, detailed energy audit requires technical expertise and more detailed field data and short-term metering or monitoring data. Also, energy audit can create a financial strain, especially higher level audits can be time consuming, and travel for on-site work pushes up cost. The proposed solution should reduce time or cost of the energy audit. In addition to proposing solutions, this challenge also asks the teams to test their proposed solution by conducting the energy audit at a local building. The solution could be related to any required task in any of the 3 levels of energy audits. For example, energy bill analysis, review mechanical and electrical system, building air tightness testing, and many aspects of the building, such as building envelope, HVAC system, lighting system, to improve the current system for energy efficiency and occupants' comfort. The solution could expand on previous audit method or develop your own innovative solutions. Next slide shows the response requirements. Problem statement, virtual site assessment, energy use analysis including minimum of 1 year data, potential target buildings, and expected impact of the energy audit are required. The examples of impact include energy saving potential, using a whole building energy simulation tool such as Energy Plus and OpenStudio, or other relevant method to capture the scientific effect of the proposed method and economic benefit and indoor environment improvement. Feedback from staff on energy audit outcomes are also required. A tech-to-market plan should include how to apply the solution on an aggregate scale, how to engage commercial building owners and motivate them to adopt the solution, and cost and benefit analysis needs to be included. A description of benefit for the stakeholder community from the proposed innovative system is important requirement as well. Here are additional resources. These resources will help you to understand general energy audit procedure and to develop an innovative ideas of the energy audits. If you have any questions or comments, please let us know. Thank you.